My dear students, hope you all are fine and you are taking care of your health. I have already provided you the study material on measurement and experimentation. Today I am going to discuss this particular chapter, that is measurement and experimentation. First of all, what is an experiment? Experiments in physics involves both observation and collection of quantitative data. It becomes quite obvious that the measurement is a very important aspect of any experimental science. First, the question that comes to our mind is how to measure. For any kind of measurement of a physical quantity, we should consider a constant quantity of same nature as a standard. Then only we can compare the given quantity with the constant quantity. Okay? So, what should be the perfect definition of measurement? So, measurement is a process of comparison. This is very important. Measurement is a process of comparison of a given physical quantity with a known standard quantity of same nature. What is this? Given physical quantity with a known standard quantity. Okay, so to express any measurement, one should know the unit in which the quantity is measured, the numerical value of the measure. So two things. Number one, the unit, and the number two, the numerical value. These two things. As for example, we can say the mass of a bag is 10 kg. It means the mass is measured in the unit kilogram and the unit is contained 10 times in the given quantity of sugar. Is it fine? So, what are the properties that we should keep in mind? The unit should be of convenient size. Number one. Number two, there should not be any ambiguity to define the unit. Number three, it should be reproducible. What do you mean by the word reproducible? It means from one unit we can get the another unit which are derived, and the value of unit must remain same everywhere. Okay, so there are four properties. Among these, the last three conditions are essential for unit to be accepted internationally. So what are the properties? Number one, there should not be any ambiguity. Number two, it should be reproducible. And number three, unit must remain same everywhere. Now we'll come to the kinds of unit. What are the kinds of unit? There are actually two kinds of unit. So fundamental units and derived units. These two kinds of units are there. So what are fundamental or basic units? Fundamental units or basic units. What are they? The units which are independent of any other unit or which can neither be changed nor can be related to any other fundamental units are called the basic units. Okay, so fundamental units means it will be independent of any other unit and it cannot be changed, or it is not related with any other fundamental units. As for example, we can say unit of mass, that is in kilogram. We can express in the unit of kilogram. Unit of length in meter. Unit of time, that is second. So clearly it is seen that these units are not at all dependent on the other units, hence called fundamental units. Now come to the derived units. The second one, that is the derived units. So what are derived units? The units which depend on fundamental units and which can be expressed in terms of fundamental units are called derived units. So these are dependent. Actually the derived units are dependent and depends on the fundamental unit. Okay, so as for example of it, we can say volume, cubic meter, meter cube, unit of area, that is a square meter, etc. So I shall discuss the other derived units afterwards. Now, our discussion will be on systems of unit. So, this may be classified into three systems. What are they? The first one is CGS system. CGS system. The first one is CGS system, or we can say it the French system. Number two, that is FPS system. FPS system, that is the British system. And number three, that is the MKS system. That is the MKS system or metric system. But these three, CGS, FPS, MKS, these are obsolete and no longer in use. Now, the modified version of the metric system, that is the MKS system, the modified version of it is the SI system, which is largely used. Okay. Now, we shall learn the fundamental quantities and their units in SI system. The fundamental quantities are recommended by International Bureau of Weights and Measures. So, what are the fundamental quantities and what are their units? The fundamental quantities are, number one, these are the quantities. These are length, mass, time, and if we write unit here, so what is the unit of length? That is meter. What is the unit of mass? That is kilogram. What is the unit of time? That is second. Mainly, these three are considered as the most fundamental units, but so many are there, so many fundamental units are there, like temperature, luminous intensity, electric current, amount of substance, angle, solid angle, these also are there. Okay, so what is the unit of the fundamental quantity temperature in SI? That is Kelvin. Luminous intensity, what is the unit? Candela. Electric current, what is the unit? Ampere. Amount of substance, what is the unit? Mole. Angle, what is the unit? Radian. Solid angle, that is the steradian. Always, it is not that we have to measure a particular physical quantity. Quantity may vary, it means it may be small and sometimes it may be large. As for example, we can say we have to measure length of a long rod and long scale. So, whenever you want to measure the length of a long rod and the length of a long scale, will you use the same quantity, same physical quantity? Yes, we will use the same physical quantity, that is length. Actually, to measure, when we want to measure a long scale, we must use meter. If it is a meter scale, suppose it is 10 meter, so we will use a unit meter. And whenever you want to calculate the length of a long rod, obviously we will use kilometer, not meter. So to express it particularly, we use prefixes with the units. For hecto, kilo, mega, giga, tera, peta, exa, etc. And for the small measurements, we use deci, centi, milli, micro, etc. These are the prefixes to measure the higher units and the small units. Okay. At first, let me discuss the units of length. Units of length. So, what is the SI unit of length? Obviously, it is meter. The related questions that comes just behind it. Define meter. In the year of 1899, meter was defined as the distance between two marks drawn on a platinum iridium rod, which contains 90% platinum and 10% iridium, kept at 0 degrees Celsius in IBWM near Paris. IBWM means International Bureau of Weights and Measures. In the year of 1983, meter was redefined as the standard meter. So what is the definition of a standard meter? It is the distance travelled by light in a particular second, that is second. Okay, so standard meter is defined as the distance travelled by light in this much second in air or vacuum. Some subunits of meter for small measurement are centimeter, millimeter, micrometer, nanometer, etc. This is the smaller unit, okay, to measure small distance, small length. Here I have told you micrometer. Micrometer. This micrometer is the 10 to the power minus 6 part of a meter. Okay, this micrometer, 1 micrometer is equal to 10 to the power minus 6 meter. Okay, so micrometer is the 10 to the power minus 6th part of a meter. Nanometer, 1 nanometer is equal to 10 to the power minus 9 meter. It means nanometer is 10 to the power minus 9th part of a meter. Okay, 1 nanometer, 1 nm equal to 10 to the power minus 9 meter. Clear? Now, for the measurement of distance between two heavenly bodies, it means it's a large distance. So, to measure the distance between the heavenly bodies, it can be done by astronomical unit, by light year, by parsec, etc. These are the large units that is used to measure the distance between heavenly bodies. Astronomical unit is the mean distance between the Earth and Sun. One astronomical unit is equal to 1.496 into 10 to the power 11 meter. So this is equal to 1 astronomical unit, 1 AU. 1 astronomical unit equal to 1.496 into 10 to the power 11 meter. Okay. Now I told you about light year. What is a light year? Light year is the distance travelled by light in vacuum in 1 year. So in 1 year, the length, the distance that is travelled by a light, that is the 1 light year. And 1 light year is equal to 9.46 10 to the power 15 meter, means more than 1 astronomical unit. Okay, 9.46 into 10 to the power minus 15, 10 to the power 15 meter. Okay, so 1 light year is equal to 9.46 into 10 to the power 15 meter. This is 1 light year. Okay, now I told you about parsec also. What is 1 parsec? 1 parsec is the distance from where the semi-major axis of orbit of Earth, that is 1 astronomical unit, subtends an angle of 1 second. Okay, so 1 parsec is more than 1 light year. Okay, the distance, that is the 1 parsec distance, is more than 1 light year, is equal to 3.08 into 10 to the power 16 meter. So 1 parsec equal to 3.08 into 10 to the power 16 meter. 1 parsec is equal to 3.08 into 10 to the power 16 meter. This is more than 1 light year. Okay, this 10 to the power 16 you can see here is equal to, we can write 3.26 light year. Okay, so 1 parsec equal to 3.26 light years. If we have to measure the very small distance, that is intermolecular separation, radius of orbit of electron, we use angstrom. Here, angstrom can be written as this one. A, the top there will be like 0, angstrom, and 1 angstrom is equal, we can write 1 angstrom equal to 10 to the power minus 10 meter. This is the relationship between angstrom and meter. Clear? And remember it that the size of nucleus is expressed in Fermi. Okay, Fermi is the another unit which is used to measure the small distance or small length. Okay, so If we want to express the size of nucleus, it is expressed in Fermi. Okay, so it is expressed in Fermi, small f, and 1 Fermi equal to 10 to the power minus 15 meter. It is even smaller than 1 angstrom. So students, now I would like to complete my discussion here, and I am praying for your safety. In the next class, I shall discuss the rest part of this chapter. Thank you so much for your kind attention. Stay safe, stay healthy. My dear students, hope you all are fine and you are taking care of your health. I have already